Hello everybody. So today we'll be going through one of the important topics, one of the important theorems or one of the important rules, which is very much related to moments, and it is called as Varignon's theorem of moments or Varignon's principle of moments. This is completely related to moments. This particular theorem or principle is very important, very important. We'll be applying the concept of Varignon's theorem in the upcoming modules in the second module and in the third module as well. So let us try to understand the meaning first. Let us try to understand the meaning and statement of Varignon's theorem of moments. In order to understand the meaning, let me consider a small example. Let me consider two forces, say force F1 and force F2. Force F2. And let R be the resultant of these two forces, force F1 and F2. Let R be the resultant of these two forces. Let me consider a point A, random point A. Random point A. Now, according to Varignon's principle or Varignon's theorem of moments, moment produced by force F1, moment produced by force F1, moment produced by force F1 about this point A, plus moment produced by force F2, about the same point A, is equal to moment produced by the resultant about the same point A, So again, let me repeat. Moment produced by force F1 about A plus moment produced by force F2 about A is equal to moment produced by resultant about the same point A. This is not applicable only for two forces, for any number of forces. For example, if you have a number of forces in a particular system, this rule can be applied. So sum of moment produced by all the forces, about a particular point, sum of moment produced by all the forces about a particular point is equal to the moment produced by resultant of all the forces about the same point. Hope this is clear. This is the meaning of Varignon's theorem or statement. Even the statement is same. Sum of moment produced by all the forces in a particular system is equal to the moment produced by resultant about the same point. Moment produced by all the forces should be with respect to a particular point. Now, this is the meaning of Varignon's theorem or statement of Varignon's theorem. Hope this is clear. Now we have to prove this. We have to prove Varignon's theorem. The statement of Varignon's theorem. In order to prove the statement of Varignon's theorem, there is an important drawing which is to be understood properly. There is an important diagram or drawing which is to be understood. Let us try to understand the diagram now. Diagram and several steps will go hand in hand. So let us try to understand the both. Yeah. So let us start proving the Varignon's theorem. Let us start proving the theorem. In order to prove, let me draw the x-axis. Let this be x-axis and let this be y-axis. Yeah. Now, let me consider the first force, and let me name it as force F1. And let this particular force make an angle theta 1 with respect to horizontal. Let me consider a random point A again. Yeah. Now, we need moment produced by force F1 about the random point A. We need moment produced by this particular force F1 about the random point A. Now, in order to find moment produced by a particular force about a random point, we need the perpendicular distance. Is it not? Moment is the product of magnitude of force, which is F1 here, magnitude of force and the perpendicular distance from the line of action of force to the point about which we need moment. So in order to find the moment produced by this particular force F1, we need the perpendicular distance from the line of action. This is the line of action of force to point. In order to find the perpendicular distance, the simplest method to find the perpendicular distance is by drawing a perpendicular line. From point A to force F1, line of action of force F1. By drawing the perpendicular line, we can easily find the perpendicular distance. And let me write the perpendicular distance as d1, which is associated with the force F1. Then, so what is d1 here? D1 is the perpendicular distance from the line of action of force to point. D1 is the perpendicular distance from the line of action of force F1 to point A. We need this particular distance in order to find the perpendicular, in order to find the moment produced by force F1 about point A. F1 about point. Now just think, theta1 is the angle made by the line of action of force with respect to horizontal. Now, we need the angle made by this perpendicular line, this perpendicular line with respect to the vertical, with respect to y-axis. We need this particular angle. We need this particular angle. How to find the angle is the question. We need this angle. Let me mark this as O, this particular point. Now, if this is theta1, this angle would be 90 minus theta1. Agree with this, everybody? So if this is 90 minus theta1, if this is 90, this angle will obviously be equal to theta1. Or these two angles, this particular angle and this angle. This is the angle made by line of action of force with respect to horizontal, and this is the angle made by the perpendicular line from A to the line of action with respect to vertical. Both the angles should be same. I'll drop this. I don't need this for a further calculation. So let me hope this is clear. These two angles should be same. Done. Now, hope this much is clear. Now let us find the value of d1. In order to find the value of d1, let me consider this as a right angle triangle. Let me mark this particular point as B. Now, in right angle triangle, OAB, in right angle triangle OAB, what is cos theta 1? What is cos theta 1? Cos theta 1. Cos theta 1 will be d1. This is the adjacent side and this is the hypotenuse. O is the hypotenuse. So d1 by OA. Cos theta 1 will be d1 by OA, or d1 is equal to OA cos theta. d1 is equal to OA cos theta 1. Is this right? d1 is OA cos theta 1. d1 is the perpendicular. So we got the value of one of the perpendicular distances. Right? This is force F1. Similarly, let us consider one more force. Let us consider it as F2. I got you. Let this be the second force, F2. Again, let F2 make an angle theta 2 with respect to horizontal. Now, to find the moment produced by force F2, let us follow the same procedure as which we followed with respect to this particular force F1. To find the moment produced by force F2 about point A, we need perpendicular distance from A to F2. Is it not? In order to find perpendicular distance, we have to draw a perpendicular line from A to F2. And let me write or mention this perpendicular distance as D2. Now, making the same concept here, angle made by this perpendicular line associated with F1 with respect to vertical will be same as that of the angle made by the line of action of force with respect to horizontal. Similarly, angle made by this perpendicular line with measurement D2 with respect to vertical, this angle will be same as that of the angle made by F2 with respect to horizontal. This will be equal to theta. Right? Same procedure, same concept will be followed for F2 as well. These two angles should be same. If this is theta 2, even this angle will be equal to theta 2. Now, similarly, let me mark this point as C. Now, with the help of triangle OAC, this is a right angle triangle, again, right angle triangle. What is cos theta 2? Included angle is theta 2 here, theta 2. Cos theta 2 will be D2 by O. Again, D2 is equal to OA cos theta 2. Right, we got the value of D2 as well. Now we have two forces, F1 and F2. We need the resultant. We need the resultant. Let me draw the resultant as well. So resultant will go in this way. Let R be the resultant of the two forces, and let R make an angle theta with respect to horizontal. Let R make an angle of theta with respect to horizontal. Done. Now, again, in order to find the momentum produced by resultant about the same point A, we need the perpendicular distance from the line of action of resultant to point A. To find perpendicular distance, what are we supposed to do? We have to draw a perpendicular line. We have to draw a perpendicular line from A to R, line of action of R. Let me draw the perpendicular line. Let me draw it somewhere here. And let me mark this as D. And let me write the perpendicular distance as D. D1 is the perpendicular distance associated with F1, D2 is the perpendicular distance associated with F2, and let D be the perpendicular distance associated with the R. Since R makes an angle of theta with respect to horizontal, even this particular line should make an angle equal to the same. So even this should be equal to theta. Yeah. So now in triangle OAD, in this right angle triangle OAD, theta is the included angle. So what is cos theta? Cos theta will be D by OA. So therefore, finally, D is equal to OA cos theta. D will be OA cos theta. Yeah. Hope this much is clear. Hope these many steps are okay and clear. Yeah. Now, let me write the values of D1, D2, and D separately. D1, D2, and D. D1 is OA cos theta 1, D2 is OA cos theta 2, and D is OA cos theta. Let me write it separately. Hope you are clear with the steps to calculate the values of D1, D2, and D. So D1 is OA cos theta 1, D2 is OA cos theta 2, and D is OA cos theta. We know this much. Right? Now we have two forces, and R is the resultant of these two forces. Now let me resolve this particular force F1, F2, and the resultant into their horizontal and vertical components. Now, if I resolve F1 into its horizontal and vertical components, horizontal component will be F1x, I'll write as F1x, which is equal to F1 cos theta 1, if I'm not wrong. Right. So similarly, vertical component will be, I'll write the vertical component somewhere here, it will be F1 sin theta 1. If I resolve R, Rx will be R cos theta, Ry will be R sin theta. Similarly, if I resolve F2 Ex will be F2 cos theta 2, and F2y will be F2 sin theta. These are the resolved components as far as these two forces are concerned. Please follow the steps properly to draw the drawing. If you go through the drawing, finally it will be a total mess. So follow all the steps properly. If you understand the step for one of the forces, you can follow the same for second force and resultant. So you draw a force makes an angle, and in order to find the perpendicular distance from the line of action of that particular force to A, draw a perpendicular line. The angle made by force with respect to horizontal will be equal to the angle made by the perpendicular line with respect to the vertical. So which is theta 1, theta 2, and theta here. And you get the distances D1, D2, and D. These are the three perpendicular distances from A with respect to force F1, F2, and result. And I have resolved this is F1x. F1 cos theta 1 is F1x. Rx is R cos theta, and F2x is F2 cos theta 2. F2 cos theta. Now, let us find the moment produced by, this is important, everybody observe, moment produced by force F1. Moment produced by force F1 about A. F1 about A. Moment produced by force F1 about A. So what is moment? It is the product of magnitude of force and the perpendicular distance. What's the magnitude of force here? Magnitude of force is F1. And what's the F1? What's the perpendicular distance? Perpendicular distance is D1 in this case. Perpendicular distance is D1. So let us simplify this further. F1 into what is D1? We know the value of D1. D1 is OA cos theta 1. D1 is OA cos theta 1 from this. Let us simplify this or let us rearrange. Let us rearrange. So finally, by rearranging, it will be OA into F1 cos theta 1. OA into F1 cos theta 1. What is F1 cos theta 1? Just observe here. F1 cos theta 1 is F1x, is it not? F1 cos theta 1 is F1x. So finally, moment produced by force F1 about A is equal to OA into F1x. OA into F1x. This is moment produced by force F1 about A. Moment produced by force F1 about A. OA into F1x. Hope this is clear. Let me write it separately. Moment produced by force F1 about A. Moment produced by force F1 about A is OA into F1x. Now similarly, let us calculate the moment produced by force F2 about A. Moment produced by force F2 about A. Again, moment is the product of magnitude of force and the perpendicular distance. What's the magnitude of force? It is F2. And perpendicular distance is D2. Let us simplify this. F2 remains as it is. F2 into what is D2? D2 is OA cos theta 2. D2 is OA cos theta 2. Now let us rearrange. Let us rearrange this. So it will be OA into F2 cos theta 2. So what is F2 cos theta? It is F2x. F2 cos theta 2 is F2x. So finally, it will be OA into F2x. Moment produced by force F2 about A. It will be OA into F2x. Let us write it separately. So moment produced by force F2 about A is OA into F2x. Moment produced by force F1 about A is OA into F1x. Moment produced by force F2 about A is OA into F2x. We need one more. Moment produced by resultant. This resultant about. So moment produced by resultant about A is equal to, again, moment is the product of magnitude and perpendicular distance. Magnitude is resultant. R into perpendicular distance is D. Is D. We know the value of D, substitute it. So it will be R into D is OA cos theta. D is OA cos theta. OA cos theta. So let us rearrange this. So it becomes OA into R cos theta. Let us refer the diagram. R cos theta is Rx now. R cos theta is Rx. So finally, let us rearrange and write it. So it becomes OA and R cos theta is Rx. This is the moment produced by resultant about the point A. Let me write it separately. So moment produced by resultant about A is OA into Rx. So we have these three now. Moment produced by force F1 about A is OA into F1x. Moment produced by force F2 about A is OA into F2x. Moment produced by resultant about A is OA into Rx. We have 1, 2, and 3. Let me name this as expression number 1. Let me name this as expression number 2, and let me name this as expression number 3. Hope this much is clear. Hope this is okay. Now, let me rub the diagram and let us finally prove it. Now, we have three expressions, 1, 2, and 3. 1, 2, and 3. So, adding expression 1 and 2. 1 and 2. 1 plus 2. Expression 1 is moment about force F1 about A plus moment produced by force F2 about A is equal to OA into F1x plus OA into F2x. Now OA can be removed as a common factor. OA into F1x plus F2x. OA into F1x plus F2x. What is F1x plus F2x? This is the summation of all the forces moving along x direction. Summation of all the forces moving along x direction. Similarly, if you add F2y plus, F1y plus F2y, it will be summation of all the forces moving along y direction. So this is F1x plus F2x, F1x plus F2x plus F2x. Or let me write it here. F1x plus F2x. Here, F1x plus F2x is summation of Fx. Agree? Summation of all the forces moving along x direction. You add the horizontal component. Summation of all the forces moving along x direction. So, in the previous set of numericals, if you remember, summation of Fx, summation of all the forces moving along x direction would be equal to resultant x component of resultant. You had two conditions where we used to find the unknown force. We had two conditions. Summation of all the forces moving along x direction would be equal to Rx, and summation of all the forces moving along y direction will be equal to Ry. So summation of all the forces moving along x direction will be equal to Rx. So F1x plus F2x is summation of Fx, and summation of Fx is equal to Rx. Summation of Fx is equal to Rx. Is it not? Hope this is clear. Now, we know that F1x plus F2x is summation of Fx, and summation of Fx is Rx. So I can replace this by Rx. So OA into Rx. This becomes OA into Rx. Left hand side is moment produced by force F1 about A plus the moment produced by force F2 about A is equal to OA into Rx. Is equal to OA into Rx. So what is OA into Rx from equation 3? So from equation 3, OA into Rx is moment produced by resultant about A. Moment produced by resultant about A. Now replace OA into Rx. Replace OA into Rx by moment produced by resultant about A. Finally, from equation 3, moment produced by force F1 about A plus moment produced by force F2 about A is equal to OA into Rx is moment produced by resultant about A. This can be replaced by moment produced by resultant. This is the proof of Varignon's theorem. Moment produced by the first force about A, moment produced by the second force about A is equal to moment produced by the resultant of these two forces about the same point. So this is how you prove Varignon's theorem. In order to prove Varignon's theorem, you should be comfortable with the drawing. Once you draw the drawing, you have to find D1, D2, and D. So once you find D1, D2, and D, you have to find moment produced by force F1 about A. You have to find moment produced by force F2 about A. Similarly, you have to find moment produced by resultant about A. And once you find, add these two equations, simplify the right hand side. F1x plus F2x is Rx. OA into Rx is moment produced by resultant about the point A. So this is how you prove Varignon's theorem. This is all about the statement and proof of Varignon's theorem, and this is very, very important. Please go through this. This is there in the notes. This is the explanation for the theorem. So please go through the video and go through the notes to understand this. Thank you.